So in terms of the exterior envelope, so here we're looking at the precast thermal mat system, and so what we're trying to look at is how we can avoid the thermal bridges at 100% of our sites worth of stormwater.
We had what some might say were naive ideas by the young graduates who asked why not. And then we had senior enough staff in education to sometimes say, yeah, why not? Or maybe this is why. We believe that this strategy and the approach in this building could be any building. And if you utilize those strategies, similar or approaching similar performance results could be achieved.
For all of the energy goals, all of the sustainable goals of the project, at the end of the day, we still wanted to make an incredible place for the occupants to come and work. And we wanted to make great architecture.
We have required our utility companies to do energy efficiency plans for decades. Part of the impetus of this building was, if we're making other people do it, we should model what can be done. So our chairman at the time had the idea that we could spend those rent funds better by building an asset for the state that could model technologies for anyone else to incorporate into a building.
And non-residential renewable program that was filed on March 1st.
Technologies involved and innovations are more about the way standard products and planning and materials are used, more than they are inventing a new product or a new piece of machinery or a new higher efficient pump or something of that nature.
The project kind of embraced a methodology of tackling all of the passive strategies first. And by passive strategies, the things that aren't kind of active systems, that involves building orientation. And so on the south elevation, the major kind of architectural articulation becomes the daylight harvesting sunscreens, getting a well-insulated kind of high-performance envelope, mitigating things like thermal bridging. And so by taking on those passive strategies, you've eliminated those energy loads that you didn't need in the first place.
Are there methodologies that we could develop in our building which are more natural rather than having to operate devices or create machines and things of that nature? The building, in a way, has to work a little bit like a camera or the human eye. It has to find a way to read and to interpret daylight.
As we're trying to get the energy model to balance out, to hit those goals, this thing had crept up from the 42-inch position to the 48-inch position. And as we're looking at interior views from the perspective of the occupant, it just started to drastically change the way you experience the building. And so we convinced everybody, even though there was I think a 2 kBTU penalty per the modeling to lower by 6 inches, and everybody just kind of said, well, we'll commit ourselves to finding that additional 2 kBTUs of energy so that, again, we're not sacrificing any of the experiential elements, because the project is really all about a high-performance demonstration, model energy efficient office building, but demonstrated it can be done with comfort and can be a great experience for the occupants.
Every team member that has a significant role in this project and how it performs is critical to the initial stages of the process, because there isn't any one part of this building that would let it perform anywhere near where it does if the other parts weren't working in total parallel with it. This whole building was about learning and sharing. There's no secrets here. There's no magic piece of equipment sitting in the other room that no one's allowed to see. It's the same materials everybody else uses. It's the same mechanical equipment everybody else uses. It just didn't have the same team everybody else uses.